All right, today we're going to take a peek behind the curtain at one of the most powerful and specialized pieces of silicon out there, Microsoft's custom-built AI accelerator, the Maia 200. In this explainer, we're going to break down why a software titan is betting its future on custom hardware, and what exactly makes this chip such a potential game changer. So look at this thing. This isn't just some off-the-shelf processor you can buy. No, this is an engine designed from the ground up for one very specific, very monumental task: to power the generative AI revolution from inside Microsoft's own Azure data centers. So you gotta ask, right? Why on earth is a company famous for software suddenly diving into the incredibly difficult and expensive world of designing its own custom microchips? Well, the answer really tells us a lot about a fundamental shift in how the future of AI is being built. To get why they're doing this, you've got to understand the bigger picture. We are deep in the middle of a full-blown AI hardware arms race. You see, the core problem is that these new large language models have an absolutely insatiable appetite for computing power. This explosive growth is creating a massive bottleneck in our infrastructure. The general-purpose chips that have powered data centers for decades, they just can't keep up efficiently anymore. It's like trying to power a rocket ship with a car engine. And this is where Microsoft's Maia 2000 enters the picture. It's their strategic, custom-built answer to this colossal challenge. And here's the secret sauce, really. Maia 200 isn't just a chip. It's the heart of what's called a vertically integrated system. That means the hardware, the software, and the network that connects thousands of them together were all designed by the same team at the same time to work in perfect harmony. It's all about tuning every single component for one job: accelerating Microsoft's AI. And man, when you code design like that, the results are, well, they're pretty jaw-dropping. Just look at this generational leap from their first chip, Maia 100, to this one. We're talking about peak HBM bandwidth. Think of that as the number of lanes on the data highway into the chip. HBM capacity is the size of the data warehouse. The backend network is how you connect thousands of these chips together. And peak tensor tops, that's the raw AI horsepower. The numbers here are just staggering. Okay, first up, that data highway, the high bandwidth memory. We're talking nearly a 4 times increase in bandwidth. That is absolutely massive. It's the difference between a country road and a superhighway. And it's all about making sure those powerful compute engines never, ever have to wait for data. All right, now let's talk about connecting these things together. The backend network bandwidth has more than doubled. Why does that matter? Because modern AI isn't trained on one chip. It's trained on thousands working in perfect sync. This network is the nervous system of that massive AI brain. And this number, wow, this really shows you what this chip was built for. Over 10,000 tera operations per second, using something called FP4. Now, FP4 is a specialized low-precision number format. Think of it like this. Instead of using a big, clunky, universal tool for every job, you're using a small, specialized, super-efficient wrench. It lets the chip cram in way more calculations, saving a ton of energy. It's all about maximum efficiency. So how in the world did Microsoft's engineers pull off such a massive leap in performance? Well, the answer is in the chip's really innovative architecture. The best way to picture this chip's architecture is to think of it like a perfectly designed city. Seriously, you've got different neighborhoods and districts, all linked out by this incredibly efficient highway system, all designed to move data around without any traffic jams. And in our city, the basic house, the fundamental building block, is something called a tile. And each one of these tiles is like its own mini factory. It's got its own specialized engines for doing the work, its own little storage room for memory, and even its own manager to keep everything running smoothly. So you have these individual houses, the tiles, and what do you do with them? You group them into neighborhoods, which they call clusters. And each neighborhood gets to share a bigger communal resource, in this case, a larger bank of memory. This whole idea is all about keeping data as close as possible to where it's being used. It's like having your kitchen right next to your pantry. It saves a ton of time and energy. But it's not just about the layout. It's the infrastructure that makes the city work. You've got this massive, nearly 280 megabytes of super fast on-die memory. That's like having local warehouses everywhere to cut down on long-haul truck traffic. Then there's the internal logistics system, this network on chip, which is like a private subway system just for data. And get this, it even has hardware that automatically converts data into the most efficient format on the fly.
It's a brilliantly designed system to eliminate any potential traffic jams.
Okay, so building a chip this powerful and Miss Smart is one thing. But actually powering it and keeping it from melting, that's a whole other beast. I mean, think about it. 750 watts. That's more power than a lot of high-end gaming PCs use, but it's all crammed into one single piece of silicon. This thing is so big, they call it a reticle-scale chip, which basically means it's as big as they can possibly make it. So figuring out how to pump that much power in and get all that heat out, that's a monumental engineering challenge.
And this graph right here shows you one of those huge challenges. See that purple line? That's what happens when a massive AI job suddenly starts. The power demand spikes and the voltage can just plummet, which would crash the entire system. But now look at the red line. That's Maia 200's built-in activity throttling kicking in, catching that drop and stabilizing everything in an instant. It's pretty amazing. So how do they do it? It's this really clever two-step process. First, they're proactive. They don't just turn on the whole chip at once. They turn on different parts in a sequence, nice and easy, to avoid that sudden power shock. But, just in case, they also have a reactive safety net. Tiny detectors on the chip sense if the voltage is dropping and instantly slow things down just enough to keep it stable. It's brilliant.
And none of this would be possible without the physical packaging itself, the thing the chip actually sits on. And this is an absolute work of art. It's got a silicon interposer. Think of it as a multi-lane bridge connecting the chip to the outside world. And it even has these tiny, super fast capacitors built right into the package. They act like little shock absorbers for the power supply, making sure the chip always gets a smooth, stable flow of electricity.
Okay, so we've seen the insane architecture, the mind-boggling power management. After all that incredible engineering, what's the bottom line? What's the big payoff?
And here's the magic number, 30%. For its own AI workloads, Microsoft says Maia 200 delivers 30% better performance for every dollar spent compared to the best off-the-shelf stuff they can buy. Now you might think, 30%? Is that it? But you have to remember the scale we're talking about. For a company like Microsoft operating the Azure cloud, a 30% improvement translates to billions of dollars in savings. That's a massive, massive advantage.
And really, this quote from the engineers who built it just sums it all up perfectly. Maia 200 is a masterclass in optimization. They pushed manufacturing to its absolute limit to create a chip that is perfectly tuned for performance, for energy efficiency, and for actually being able to build it at scale. So what does this all mean for the future? The success of a project like Maia 200 really forces us to ask a big question. Microsoft, Google, Amazon, they've all shown that if you're big enough, building your own custom chips gives you a huge leg up. So as AI just keeps getting bigger and hungrier, is this the future for everyone? Is the next wave of innovation going to be built not on general purpose chips, but on custom designed, purpose-built hardware? Now that is something to think about.